Hello everyone, my name is Yu. I come from Worcester Polytechnic Institute. Today I'm going to introduce our work Beyond the VPN, Practical Client Identity in Internet with Widespread Address Sharing. VPN is used by a lot of enterprises to connect their remote network users to their on-site network. There are some features come with VPN. So it can protect the data confidentiality and authenticity. It can also manage the communication. For example, the enterprise network will not allow their employees to work when they are, to watch the Netflix when they are working, and it can also simplify the access control. However, there are some drawbacks come with VPN. First one is the bandwidth bottleneck. So there are some enterprise networks they just deploy dedicated VPN server for VPN service, which is not like professional VPN gateway, which has a much better performance. The other one is a redundant encryption. So the VPN encrypts the traffic again, even though it's upon HTTPS, which is mostly used today. And some of the enterprise networks they use a third-party VPN service, which would be very expensive. So given this background, we know that VPN could be has a lot of redundant functionalities and it has some drawbacks, except it can simplify the access control. So our researchers really want to find out a lightweight access control method for to replace VPN, and then we can remove those redundant functionalities. So our system, we're going to design dynamic identifier insertion system based on software-defined networking technology, and we're going to we have developed open source IP-enabled modules to help organizations to deploy our method easily and conveniently. Before going through our method, we have to go through some background knowledge. So IP addresses was originally designed for recognize a remote user. However, IPv4 addresses already run out. So people developed carrier grenade, the CGN, to have this transition from IPv4 to IPv6. There are some features come with CGN, like dynamic and shared IP addresses. So for example, a host usually get a private IP addresses from their internet service provider. So from the organization's network's perspective, the public IP address it observes from the client usually is shared by a lot of more people. So they cannot just recognize a remote user from just the IP addresses. CGN has been developed to 92% of the cellular networks, and with a growing development of 5G networks, there will be 30 million residential networks affected by this technology. There are some previous work focused on how to split the functionalities of the identifier and locator from public IP addresses. However, most of their methods are going to need to modify the intermediate network infrastructure, which we believe is very hard. So in our paper, we're going to use a standardized protocol IP. So basically, we have an outer IP header, which is used for routing the packets, and the inner IP header, which is used for conveying all identifier information. So our system, we're going to design systems that to help the organization networks to distinguish the users who, even though they are sharing public IP addresses with others. We are going to design a system providing first pass authentication information, and the robust authentication is left to the application layer, like the traditional username and password authentication. So our system is going to is designed to defend on the SAD attackers. Our system is designed to Kerberos-like protocol because it's used by a lot of companies, like especially those who use Active Directory provided by Microsoft. There are two components in our method. The first one is key-transfer, and the second one is key-verification. However, before that, the client needs to indicate the support of our method. When the client sends out a request to the authentication server, the first packet of this flow is going to be elevated to the controller. Controller will encapsulate the packet into IP, and the authentication server will see it, and it learns that the client supports our protocol. Then it will generate a client key and insert it into the API packet and send it back. When the controller receives it, it will extract the client key and decapsulate the packet, store the client key into its local database, and send the packet out. So when the client sends out a request to the application server, similarly, the first packet is going to be elevated to the controller. The controllers can look up its database, and if it determines that the client key is applicable, it will insert it into API packet and send it out. So the application server can use our open source API tables module to verify the client key, and if it's valid, it will decapsulate the API packet. If it's not valid, it will drop the packet, and then the packet will go reach out to the applications. We have developed our system in a lab environment to evaluate the effectiveness and performance. However, we're using a remote SDN controller to evaluate the round trip time for our local network to controller in the real world. Firstly, we evaluate the effectiveness. So we found that only if the users can provide with a valid token, it can get access to the application service. Otherwise, they will not. Next, we evaluate the performance. On your left-hand side is a component of key transfer. The right hand is key modification. We use a green line to show a round trip time from our local network to the controller. Round trip time. So this is used for comparing the how much time we add up our system adds onto that. The blue line shows just an idle SDN architecture, and the right line shows a full implementation of our method. So as a result, we can see our system just as like 1 to 10 milliseconds to the 4 to 10 milliseconds to the original system, because this network delay only applies to the first packet of each flow, so we believe it's not going to be perceived by the users. So as I mentioned before, this system just provide information for first pass authentication, and the robust authentication is left for application layer. So we just depend on the SAT attack. However, but the on-pass attackers can observe our packets, and there is also some privacy concerns. To conclude our work, we have identified that VPN has some redundant functionalities. We're trying to remove those redundant functionalities and have a simplified access control left for organizations. We have developed an open source API tables module for organizations to easily deploy our method. We also have evaluated this method to be effective and efficient. That's it for my today's talk. Thank you very much.